Good day, students. So in our last video for this unit, we're going to talk about how proportionality applies to shapes, or what are known as similar figures. So in the previous video, we talked about how we can classify if a shape is similar or not. If we are given similar figures, like we don't have to determine that they're similar or not, like they already meet all the criteria. One of the things that we can do is apply proportionality to finding one of the missing sides or the missing angles of a particular shape. So what we're going to do is we're going to do two examples. So I'm basically splitting the page in half. So if you want, you can kind of split your page in half and copy down the first example. You can take a moment to pause and do that. Okay, so you can see in these two triangles, we can assume they're right triangles if you want. They don't tell us that, but we can assume that. It's not really going to change our problem. But we have triangle ABC and DEF. And in triangles ABC and DEF, the right angle is down here. So angle B and angle E, which means that angle A and angle D should be congruent or equal to each other. And then angle C and angle F should be congruent or equal to each other. They're telling us that these are similar. Like we don't have to go prove it. But they do tell us that the length of this side, AB, is 15, and the length of its corresponding side in the similar triangle is 5. And then they want to know if like this side right here is 6, well, what does this measurement here, what does the length of this triangle have to be? So you'll notice we're going from a bigger to a smaller triangle. So that means our scale factor is actually going to be a fraction, because we're either like taking half, a third, a fourth, a seventh, an eighth, like we're decreasing this shape to a smaller size. So in order to figure out like what the value of this piece is, we need to look at the corresponding sides. So we can set up proportions two different ways. We can set it up as like per triangle. So I could set up a proportion of 15 to 6 is equivalent from 5 to X, or I can set up proportions between corresponding sides. So like 15 to 5 and 6 to X, because they're proportional and corresponding to each other. So AB, that's what we're going to call the length of this side. AB corresponds to DE in the smaller triangle, and BC corresponds to EF in the smaller triangle. So if I wanted to write them like proportions, I could write it like this. AB to DE corresponds or is equivalent to BC to EF. And you're like, Ms. Walker, this is a lot of letters. Like, this is just math. Like, what are we doing? So what I can do is I can replace them and solve a proportion. So AB is 15. That is the length they give me. DE is 5. BC is 6. And EF, I don't know. So I can just use X, or I can use it as EF. So basically, I took the corresponding sides, and now I have a proportion. If I cover all this up, now I have a proportion that I can solve using crossroads or cross multiplication. Okay. So in this case, 15 to 6, there's not really a perfect, factor. So I can just set it up like using cross multiplication. So 15 times X is 15X. 5 times 6, if I use cross multiplication, is 30. So X in this case, 15 times what makes 30? I could use depot, and that's going to be 2. Okay, so X is equivalent to 2 in this scenario. This is how you would set it up as a proportion. You can also kind of just see it. I don't know if that makes sense, right? 15 to 5, you're dividing by 3, right? So that's how you get 5. And then if you do the same thing, because you want to keep it proportional, 6 divided by 3 is equal to 2. So that's another way to kind of see it. The scale factor, what we decreased the shape by, because we went from a bigger to a smaller amount, is since we divided by 3, essentially what we did is this is 1/3. So the scale factor is 1/3. So if I said create a similar triangle to this, that is 1/3 the size of it, you would have to decrease everything by dividing it by 3. So the scale factor is 1/3. Okay. So we solved for the missing side by setting up a proportion. We identified what the scale factor is, and this is kind of how we apply proportionality to a shape. Let's look at a little bit more complex example. So you can go ahead and take a moment to pause and copy down the information. Okay, so essentially what we have in this problem is we have like one triangle laying on top of a bigger triangle. So we have ABC, which is the smaller triangle, and then ADE, which is the bigger triangle. You can almost kind of think about if this center line wasn't there. I don't know if you guys heard that like honking or squeaking in the parking lot next to me. If you did, I'm so sorry. If you didn't, let's continue on. So they tell us that triangle ABC is similar. Remember that symbol means similar. Is similar to triangle ADE. So I kind of broke the triangles down into like, where they're not on top of each other. So this would be ABC, and this is ADE. So I kind of like separated them, and I'm just going to label. So they say this is 33, BC is 13, and then AD we don't know. AE we don't know either. And then they tell us that this is 91. Okay, so this is kind of the information they give us. They want to know what is the length of AD. So we're trying to figure out this particular side. So if we know that they are similar to each other, we can just use what we know about the sides and figure it out. So if I want to just kind of do it without setting up a proportion, if I'm trying to look at how am I going from 13 to 91, well, I'm increasing. So I'm going to be multiplying by something. 91 divided by 13 is actually 7. So 13 times 7 is 91. And if I want to go from 33 to X, I just have to do the same thing. 33 times 7. And 33 times 7 is 231. So X is equivalent to 231. If we do it without setting up a proportion, if we just kind of look at it that way, if we wanted to set up a proportion, okay, we can set it up between the two triangles. So 33 over 13. So this particular smaller triangle, this is equivalent. So the corresponding side. So the corresponding side here is AD, which is X. And then the corresponding side is DE, which is 91. We could set up the proportion like this, and then solve either using crossroads or cross multiplication. It ends up being the same thing, right? We can use crossroads times 7. And again, we get the same thing. X is equal to 231. So that is the length of the side. So if you see a similar figure like this, I would suggest kind of separating it so that way they're not overlapping. We didn't identify the scale factor here. The scale factor, we're going from a smaller shape to a larger shape. So the scale factor is going to be a positive number. Well, it's always a positive number. I shouldn't say that. It should be a number that's greater than 1 because we're increasing it. So we're increasing it by 7. So the scale factor is 7. So scale factor is what we either multiply or divide by in order to figure out the problem. However, if we divide, up above, we talked about how it needs to be written as a fraction. So the scale factor is 7 because this particular triangle is 7 times the size, even though it doesn't really look like that, is 7 times the size of this smaller triangle. So this is how we find the missing side lengths using proportions in similar figures. So I'm going to give you 2 examples, practice questions, I guess I should say, to do. So your first one, you have 2 rectangles. You need to find the length of the side X. And then you have 2 right triangles, and you need to find this also the length of the side X. You might be able to kind of just identify what it is by like looking at the corresponding sides. However, I would encourage you to write the proportion so that way you can practice it, so that way you can see, because sometimes it's not super obvious. So you do need to set up the proportion and then cross multiply. If it's super obvious, like you can just identify what is a scale factor and figure out your answer. But if it's not as obvious, please set up the proportion so that way you can solve it appropriately. If you have any questions, please feel free to ask your teacher. Check your answers in the table of contents. And I hope you guys have a great day. Goodbye.